Okay, this is lesson 5A. In lesson 5A, we're going to work on some of those algebraic word problems. And we're going to start with some of those translations to mathematical expressions. And we have done some of these before. So just a small review of translating something like the sum of x and y. And it's nice to know the word sum there means that you're adding them together. That's actually the answer to an addition problem. So when we have the sum of x and y, it's x plus y. We're not doing anything else with that sum, just x plus y. The difference is like the sum, except the difference is subtracting. Now, when I said like the sum, what I meant was the difference is the answer to the subtraction problem. So we need the answer to the subtraction problem, and then we're going to take twice that answer. So to make that happen, you do need parentheses. So the difference of a and b would be a minus b. Twice the difference would be 2 times the answer to the subtraction problem, a minus b. 10 less than the product of 5 and a. A lot of people mix this up. This is not 10 is less than, it's just 10 less than. So an is less than sign, let's see if I was going to write is less than. So let's say I had 10 is less than x, then this would be 10 with an inequality sign is less than x. Okay, so is less than is different from less than. Now, when you have 10 less than something, you are actually subtracting 10. Think about it this way. If you were on a diet and this week you weighed 10 pounds less than you did last week, then you wouldn't take 10 minus your weight last week. You would take your weight last week minus 10. So 10 less than something means we're subtracting 10. We're subtracting 10 in this case from the product, which is multiplication of 5 and a. So it's going to be 5a. That's the product of 5 and a minus 10. And that would be 10 less than the product of 5 and a. Number, 1D, 12 more than. So now we have more than, kind of like less than, just means that we're adding 12 instead of subtracting 12. And we're going to add 12 to twice the sum. Okay, now remember, the sum is the answer to the addition problem. And to take twice that answer, we need to put that addition problem in parentheses. So the sum of 3 and a number. The sum of 3 and a number, that would be 3 plus a number. Okay, that's the sum. I want to do something with that sum, so I'm going to put it in parentheses. And the thing I'm going to do with it is take twice that amount, so twice the sum. So now I have twice the sum of 3 and a number. And I need 12 more than that. So I can add 12 to either the left side or the right side. It just doesn't really matter. I'm going to add 12 to this side over here. So that right now is 12 more than twice the sum of 3 and a number. Now on the end of this one, we have is 57. So that is, it's kind of like is equivalent to, that's our equal sign, equals 57. Now, if we have to find the number, this one, we would solve that equation. And to solve that equation, you would do the following, distribute the 2. So you'd have 6 plus 2n plus 12. You could combine like terms like the 6 and the 12. So you'd have 2n plus 18. Then you could subtract 18 from both sides. And if you did that, that would be... I'm going to have to subtract 18. So that would be 39. So that would be 2n, right, equals... I skipped a few steps here just because I crunched for space on this one. And I think I got 39 when I did 57 minus 18. If you're not sure how we got 39 or 18, then distribute the 2, combine like terms, and then divide it by 2 to get n equals, 39 divided by 2. Well, it's going to be 19 and a half. I believe. Okay. So now we can write the equation and solve it to find the missing number. Let's try that next one. So on that next one, we have the sum of the squares of 3 and a number. Okay, so the square of 3 and a number, we're going to add them together. So we need the square of 3, so that's 3 squared. And we're doing the sum of the squares of 3 and a number. So the squares of 3 and a number means I think I'm going to square the 3 and square the number. So that's 3 squared plus n squared. So that's now the sum of the squares of 3 and a number is the same as, there's our equal sign, the square of 5. So 5 squared. Now if we wanted to find that number, which we could take 3 squared, which is 9, 5 squared, which is 25, subtract 9 from both sides to get n squared equals 25 minus 9 is 16, and then square root to get n equals 4. So anyway, that's what we're going to be working on in lesson 5, solving some word problems, finding the solution. Not just writing the equation, but finding the solution. So when we do a lot of these, what you might want to do is pause the video. I'll tell you what, on each example, we have an A and a B. Okay, so like we can do A together. Then you could pause the video, try B on your own to see if you can solve problem B. And then start the video up again and see if you are correct. Okay, so let's try problem 2A. The sum of two numbers is 180. Now, this is a really important statement right here because it tells us generally what's happening in the problem. We have two numbers. I don't know either number, like yet, because I haven't read the rest of the problem. But I know that when I add them together, I'm going to get 180. Okay. Now, it's telling me about the first number. Okay, so there's a couple different approaches people take to problems like this. If there's two things you don't know, like on this one, where there's two things we don't know, you can use two variables. But when we write our equation that we're going to solve, you want to write it with all one variable. Here's what I mean. Let's say the sum of two numbers is 180, and we want the first number, always label everything that you're going to use, is going to be x, okay? And the second number is going to be y. Second number equals y. Okay. And that's fine. You can use two variables. That way, when you have the sum of two numbers is 180, then you know that x plus y equals 180. But see, we can't solve that equation because there's an infinite number of solutions to that equation. Because what if x is 179 and y is 1, or x is 178 and y is 2, and so forth? You see? So we need the rest of the problem to determine, like, what are the other relationships between those two numbers. So the first number is, okay, now see the word is right here? That's our equal sign for the first number. Let's go over here to where we wrote our first number. And the first number is, there's our equal sign. Now we're going to write 12 less than twice the second number. Okay, so 12 less means we're subtracting 12. So we're subtracting 12 from twice the second number. So we need to take twice the second number, 2y, right? Because the second number we said is y. So that's twice the second number, 12 less than that, minus 12. Find both numbers. So now what we're going to do is we're going to use this 2y minus 12. Yeah, don't get your variables mixed up if you use two variables. So we're going to use that 2y minus 12 to represent the x. So come back over here to our equation where we wrote the sum of two numbers is 180 and change that x into 2y minus 12. Now, we still have, and don't forget this part, we still have the y. See, we still have the rest of that equation, plus y equals 180. So we kind of just used substitution. This is the equation we're going to solve. That one right there. So when we started out and we said the first number is x and the second number is y, we made it so that we had to do like an extra step, which is okay, because a lot of people like get it better that way. The extra step we had to do was to finish writing this expression for that number and put it into our equation so that we would have an equation we can solve. You'll know you can have an equation you can solve when you have all one variable. See, we have 2y minus 12 plus y. We don't have x and y, we just have all the y's. So let's go ahead and solve that one. So 2y plus y, that would be 3y, minus 12 equals 180. And then we could add 12. 3y equals 180 plus 12 is 192. And then divide by 3 to get y equals 192 divided by 3 should be about 64. So if y is 64, now it says find both numbers. So be sure to do that. So the second number, y, is 64. There's two ways to find the first number, and you should probably use both ways to find the first number. One way to find the first number is to take the 64 and put it in place of the y right there, and that's 2 times 64, which is 128. 128 minus 12 would be 116. Okay, the other way you can find in this problem is to go back to this equation. Remember, the sum of the numbers is 180, and we could just take 180 minus 64 because these two numbers have to add up to 180. And if we do that, 180 minus 64, that should be the same answer. If it's not the same answer both ways, then you made a boo-boo on the 64. So that would be a good way to check to see if you are correct. Like solve for the second number both ways. All right, so pause the video, try problem B, see if you can solve that one. And then start the video back up and check your work. Okay, you probably started the video back up now. A total of $11,000 to be divided between Sean and George. Okay. Now, in the rest of the problem, it doesn't tell you how much Sean's going to get and how much George is going to get out of that $11,000. But here's what we do know from that statement. The amount that Sean is going to get, I'm going to use, a variable S is not great, but the S is the amount Sean's going to get. Okay, so Sean's share, S. You can use X if you want to. And George's share of the $11,000, G. Okay, so we know that the amount that Sean gets plus the amount that George gets is going to be $11,000. Okay, now let's see. George is to receive okay, so it's telling us about George. So George is to receive $1,000 less. So we're going to subtract 1,000 from something. Then twice the amount that Sean receives. $1,000 less than twice the amount Sean receives. So that's going to be 2S. Twice the amount Sean receives minus 1,000. That's $1,000 less than twice the amount Sean receives. So this, we're going to put in place of the G in our equation over here. So now we have S plus G is 2S minus 1,000 equals 11,000. Combine like terms, S plus 2S is 3S. You probably added 1,000 to both sides already. I'm going to go ahead and do that here. Save myself a little bit of room. So 3s equals 11,000 plus 1,000 would be 12,000. And divide by 3 to get s equals 4,000. So Sean is supposed to get $4,000. George, well, let's see, 2s is going to be 2 times 4,000. That's going to be 8,000 minus 1,000. That would be 7,000. And 4,000 plus 7,000 does equal 11,000. So that seems to be correct. All right. Hey, let's continue in this manner. Like, there's going to be 2 problems next page. Like, we'll solve one together, and then you try to solve the other one and check your answer by continuing the video. Okay. Let's see. Problem C. A 76-inch piece of ribbon is cut into 3 smaller sections. The longest section is 24 inches longer than the shortest section. The third section is 12 inches longer than half the shortest section. Find the length of each section. Holy smokes. Okay. See, look at the end where you have to find the length of each section. How many sections are there? 3. So you can call them the first section and the third section and the second section, or I'm going to use the names that are in the problem. See, one of these sections is called the longest section. Okay? And then another one is called the shortest section. And the other one's called the third section. Oh, I should have put the shortest section up there, and then I'll just have to put the third section here. So it doesn't really matter. You can keep them first section, second section, and third section if you want to. That's fine. And if you want to use 3 variables like we did on the last one, that's fine. Do you want to use x, y, and z? Or do you want to use L, T, and S? Either way is okay. Now, originally, this ribbon was 76 inches long. So these 3 sections have to add up to 76 inches. So we know that L plus T plus S equals 76. Now, we have to read to see how they're related to each other so we can write an equation we can solve. So the longest section is, there's our equal sign, 24 inches longer. So the longest section is 24 inches longer than the shortest section. Okay, well, I'm going to use S for the shortest section. Make sure you make a nice S so it doesn't look like a 5. The third section, okay, now we're in the third section, is 12 inches longer. Okay, 12 inches longer. That's 12 inches longer than half of the shortest section. Longer than half of the shortest section. Okay, and then the shortest section is just going to be S. So now we're going to go to our equation and then put, in place of the L, see, in place of this L right here, we're putting 24 plus S. Substitution, 24 plus S. Plus, we can change colors there. The T, in place of this T, we're putting 12 plus 1/2 S. Then we also still have plus S and equals 76. So you have to remember to write the rest of the equation. And then all you have to do is combine like terms and solve your equation. Okay. We could save some time here if you want to. Well, we'll solve this one together, but after this, then I might skip ahead a little bit. So you have the 24 and 12, that's 36. Plus, now this S is 1S. This S over here is 1S. So that's 1 plus 1, that's 2, and a half, that's 2.5 S. So you can make a decimal, 2.5, because it's a nice decimal. If it was a repeating decimal, I wouldn't do it. If it was like 2/3, 2 2/3, then I would not make it 2.6 repeating, no. Don't forget your variable. So 2.5s equals 76. And then solving from there, you would subtract 36. I'm going to skip writing that part. 76 minus 36 should be about 40. You would divide by 2.5. 40 divided by 2.5. 16. So s equals 16. So now we can come over here and write in our solutions. S equals 16. The longest side would be 24 plus s, so 16 plus 24, that should be 40. And 12 plus 1/2 s. 1/2 s would be half of 16. That's 8 plus 12. That would be 20. So let's add them up to see if we get 76. 40 plus 20 plus 16 is 76. Yes. Okay, so you try problem D, and then we'll check your answer as soon as you're finished. Okay? Pause. Okay, so you probably wrote down, and I think this is important, so write down all of your unknowns here. See, that way we have a way to like write down what the unknowns represent. You know, the variables have to represent something. So if you have the first angle is x, and the second angle is y, and the third angle is z, that's okay. And then you know the sum of all three angles is 180, so that's x plus y plus z. Now, you don't have to use multiple variables. Like, you can skip this step here, and that would be okay. That's probably the way you learned to do this the first time. Okay, so the second angle is 5 degrees less. Second angle is 5 degrees less, so we're going to subtract 5. 5 degrees less than the first angle. Oh, okay, so that's the first angle is x minus 5. Okay, the third angle is 10 more, so the third angle is 10 more than 3 times the first angle. 3 times the first angle. Okay, so there's what we have. See, you could have just left off the x, y, and z and then just written the expression for the second angle and the third angle based on some other unknown, which would have been the first angle. Sometimes it's safer to do this because you won't skip any. Okay, so let's do the substitution. And then we have the x. The y is now going to be x minus 5. The z is going to be 10 plus 3x. And then you can combine like terms. That's 3x. There's another one. That's 4. That's 5. That's 5x. We have a negative 5 here added to a positive 10. So that's going to be a plus 5. And then you can subtract 5. And divide by 5. What is 175 divided by 5? Is that 35? I think it is. So if that's 35, remember we have to find all three angles. Don't just stop after you find x. Then this would be 35 minus 5, that would be 30. And this would be 3 times 35 plus 10. 3 times 35 is 105 plus 10, that would be 115. Add those up to see if we get 180, and I believe they do add up to 180. That would be important. Okay. The next one. Problem E and F. Okay. So in problem E, a total of 18,000 is to be invested, some in stocks and some in bonds. All right. Do we know how much in stocks and bonds? No. So I'm going to have the amount invested in stocks. I'm going to use X because using S is a little sketchy because it looks like a 5 sometimes when I write it. And bonds, I'm going to go ahead and use B for bonds because that way I'll know which one's which. Okay. The amount invested in bonds, here is twice the amount invested in stocks. Oh, I forgot to write something else important. A total of $18,000 to be invested, which means the amount invested in stocks plus the amount invested in bonds is $18,000. Okay? So now we have already from the amount invested in bonds is twice the amount invested in stocks. We have our expression here for the B. So we're going to use X for the stocks and 2X for the bonds because B equals 2X. So this B is 2X equals 18,000. Then you could just combine like terms. 3X equals 18,000 and divide by 3. So if you divide by 3, 18 divided by 3 is 6. So that would be 6,000. So $6,000 invested in stocks. Let's go over here and write that. 6,000. And that would mean 2X, which is 2 times 6,000, would be 12,000 invested in bonds. Sounds about right? Stocks are a little riskier, so you want to invest some, but keep the bulk of your investments in secure bonds. Okay, so try the next one. Pause the video and check to see how you can do that. Okay, so look and see how you did so far. I'm not quite finished, but I have the angle and the complement. See right there in the last sentence, find the angle and the complement. So I just wrote down, that's what I'm looking for, the angle and the complement. And I used A and C. And it says complementary angles are two angles whose sum is 90. So A plus C equals 90. And the angle is 15 less than twice the complement. So that's 2C minus 15. So now I have 2C minus 15 plus C equals 90. Combining like terms. And now we can add 15 to both sides. To get 3C equals 105 and divide by 3. So I believe that's 35. So if C equals 35, then 35. This is 2 times 35 is 70. 70 minus 15 is 55. And then we can add those up to make sure they add up to 90. Excellent. Okay, let's try another one. Now these two problems are not quite as similar as the other pairs of problems that we have done. So we might just solve both of these together. So on that top one up there, G, 48 decreased by a number is the same as the difference of 4 times the number and 7. Now in this one, it doesn't say that we have two missing things. We don't have an angle and a complement or the first section, the second section, and the third section. We don't have all that. We just have a missing number. So decreased by a number. So the only thing we don't know is the number. So we just need one variable, n, to represent the number, or x. And then we could just write the equation from the problem. So 48 decreased by a number. 48 decreased by a number is the same as equals the difference, so we're going to subtract, of 4 times the number, and 7. We're going to subtract 4n and 7. And there's our equation. So solve that equation really quick. I'll give you a minute. I'm going to add n to both sides, and then I'm going to add 7 to both sides. So I'm going to get 5n. 7 plus 48 is 55. And divide by 5 to get n equals 11. Now, there isn't really a good way of checking to see if this is right, except for plugging that 11 back into either the word problem to see if it fits the word problem. So 48 decreased by 11, and then you'd have to do the math. 48 decreased by 11 would be 37. That's supposed to be the same as the difference of 4 times the number, so 4 times 11 is 44, minus 7 would be 37. Or plugging it back into the equation that we wrote. Now on problem H, we have the square and the equilateral triangle have the same perimeter. You have to know something about perimeter of a square and an equilateral triangle. So the perimeter is the distance all the way around. Whenever you have a geometric figure in a problem, label it with all the possible labels that might help you. Okay? So if this is a square, then what do you know about the sides of a square? So all the sides of a square would be the same. So if this side is x plus 5, then this side is also x plus 5. This side is also x plus 5. And this side is also x plus 5. Okay? The perimeter of the square would be all the sides added together, all the distance all the way around. So that would be x plus 5 plus, x plus 5 plus, x plus 5 plus, another x plus 5. The triangle is an equilateral triangle. What do you know about an equilateral triangle? All 3 sides are the same. So if this side is 3x, then that means this side's also 3x, and this side's also 3x. So the perimeter of a triangle would be all 3 of those sides added together. That would be 3x plus 3x plus 3x. So if they have to have the same perimeter, here's what we're going to do. We're going to have the perimeter of the square equal to the perimeter of the triangle. So the perimeter of the square would be all of those x plus 5s added together. Now you could do it like this. 4 of the x plus 5s, right? Or you could just add them all together in your head and say that's going to be x plus x plus x plus x, which is 4x, plus 5 plus 5 plus 5 plus 5, and that would be 20. And for the triangle, the perimeter would be 3 sides that are all the same, and they're all 3x, all added together, or 3 times 3x, and that would be 9x. 3x plus 3x plus 3x. And then there's our equation. So you could subtract 4x from both sides. And then you would have 20 equals 5x. And you could divide by 5 to get x equals 4. Now, at the end of this problem, it says, find the length of the side of the triangle. So if this was a test question and you solved it correctly, just like we did, and you said x equals 4, and that was multiple choice, and you chose 4, then you would have done all the math right, but missed the problem. So be sure to read the question at the end and answer the correct question. So the side of the triangle would be 3x, and if x is 4, then it's going to be 3 times 4, which is 12. So the length of the sides of the triangle is 12. You could check your answer by putting 4 in place of the x in the square also, and that would be 4 plus 5, and that would be 9. That perimeter would be 4 times 9, or 36. This perimeter would be 3 times 12, which is also 36. So the perimeters are the same. But the question answered is the side of the triangle is 12. Okay, let's try these two. Here we go. These are more like real life plans. I don't know if you're going to see this as a real life problem, but it is designed that way. So let's take a look. Tim is choosing between 2 cell phone plans that offer the same amount of free minutes. Singular plan charges $39.99 a month with an additional minutes costing 45 cents. Whew. Verizon plan costs $44.99 with an additional minutes at 40 cents. Those must be the international plans. How many additional minutes will it take for the two plans to cost the same? Okay, so when you have a problem like this, be sure that you notice what it is they're asking for. And on this one, we only have one thing that they're asking for. So we're only going to have one unknown. And so you're searching for, where is the question? The question in this one is, how many additional minutes? So we're going to let our variable, we can use m to represent the additional minutes. Now, I don't know what else goes into this problem yet, so that's why I'm going to use the word additional minutes. I'm not just going to say m equals minutes, because I'm not sure how that equation is going to go. Okay, now, what do we know about the additional minutes that we're looking for? Well, we're looking for the number of additional minutes that it will take for the two plans to cost the same. So, see the words the same right there? That's our equal sign. So we're going to put our equal sign in between the cost of the two plans. So we have the singular plan cost is going to be equal to the Verizon plan cost. Okay. Now, how do we figure out the singular plan cost? That will help us write our equation. Well, the singular plan charges $39.99 per month. Okay, so they start with $39.99. With additional minutes costing 45 cents. So plus 45 cents for, that should say for each additional minute. I don't know if you interpret it that way or not. That's for each additional minute. So that's a rate per minute, that 45 cents. So plus 0.45. But that's only for one additional minute. We don't know how many additional minutes, so we have to multiply that by m. Okay. The Verizon plan costs $44.99. Why do companies always end with that 99 cents? And additional minutes cost 40 cents. And that's like 40 cents per minute again. So plus the additional cost for the additional minutes, 0.40. Once again, that's just for 1 minute. If we just write 0.40, we don't know how many minutes. So that's why we have to multiply that by the number of minutes, m. So this is like a comparison equation where we have the cost on one side. We're trying to make it equal to the cost on the other side. Sometimes it won't say for the two plans to cost the same. Sometimes it'll say, which plan's better? And then you're going to have to figure out that, well, I want to know when are they going to cost the same? And your equation would look like this. So let's solve this. It's not as hard to solve as it looks. Let's just subtract 0.40 m from both sides. And I'm running short on space, so I'm also going to do something else at the same time. On the left-hand side with my minutes, 0.45 minus 0.40 is 0.05. So that's 0.05 m. Okay? But at the same time, I'm also going to subtract 39.99 from both sides. Because see, that way they cancel out over here. And 44.99 minus 39.99 is like $5. You don't need those decimal points on there if you don't want to. So then we could divide by 0.05. And m will be 5 divided by 0.05, 100. I should have guessed that, but I just didn't want to make a silly error in calculation. So that would be 100 minutes. After 100 minutes, the plans are going to cost the same. If you want to check your answer, you could take the 100 minutes and put it into this calculation right here. And take your 100 minutes and put it into this calculation right here and see if the Verizon plan and the Singular plan come out to cost the same. All right, so try the next one on your own, like pause and try, and then we'll come back and check. Okay, so check, see how we're doing so far. And we're looking for how many downloaded songs. So I let X equal the number of downloaded songs. And we're trying to make the price of the Napster cost the same as the iTunes. So I wrote the Napster cost equals the iTunes cost. That's what we're trying to achieve with our number of downloaded songs. The iTunes costs 99 cents per song, and there's no membership fee. But Napster costs 89 cents per song, but there's a $10 membership fee. So there's our equation. How did we do? We can subtract 0.89 x from both sides to get 10 equals 0.99 minus 0.89, that's 10 cents. So 0.10x, then we could divide by 0.10 to get x equals 100. So 100 downloaded songs, then at that number of songs, iTunes will cost the same as the Napster. So you can use your own downloading habits to determine which service is best for you. All right, let's look at a couple more. These are also very similar to the last two because we're comparing things. So let's take a look at that K problem. In the year 2000, Ohio's population was 11.4 million and increasing by 0.5 million each year. Michigan's population was 9.9 million, increasing by 0.6 million each year. Why are more people moving to Michigan? Don't know. Oh, the retired people because they like fishing. When will the two states have the same population? Let y represent the number of years. So in this one, we know that we're looking for when will the two states have the same population, and that when is going to be the number of years, and we already are going to use y for the number of years. Okay. And the number of years we're looking for is the number of years where the Ohio population is the same as the Michigan population. So in the Ohio population, we had 11.4 million, and it's increasing. So we're going to start at 11.4 million. Now, I think we should probably write out those numbers instead of just using 11.4 and 0.5. 11.4 million is 11,400,000. And it's increasing by 500,000 each year, so that would be 500,000 each year, and so we have to multiply that by the number of years. See, if we only added 500,000, that would just be for 1 year, but see, we don't know how many years we have to do that, so we have to multiply that by y. The Michigan population was 9.9 million. That's 9,900,000. Okay. And it's also increasing, so add 0.6 million each year. That would be 600,000. Y. Okay. Now solve that, and somebody else besides you solve it again using this instead. What if we use 11.4 plus 0.5y equal to 9.9 plus 0.6y? Check to see if we would get the same answer on both of those. No, seriously, do the math. See if it comes out to be the same answer. Let me know your result. Okay, did you get the same result? Well, my result on this one was 15 years. So on this one right here, think about this. If I divided both sides by 1,000,000, is that allowed? Algebraically speaking, I need one more zero there. I'm dividing by 1,000,000 on both sides. Am I in fact doing something that is algebraically allowed? I think so. We have the division property of equality. As long as I'm dividing the whole side on both sides by 1,000,000, that should work. And I should, in fact, get the same answer. So hopefully, no matter which way you did this, you ended up with 15 years. Hopefully I didn't make some silly error, but, check my work there. Okay, and then let's take a look at this last one. Mary decided to open a business selling bracelets. Her startup cost for Mary's new business was $45. Each bracelet she sells, she earns $2.50, but also costs 75 cents for the materials to make each one. How many bracelets will she have to sell to break even? The break even point is when the income equals the expenses, or when the profit equals 0. Okay, so just in case you don't need to know, profit, there's a formula for profit. And it's just income minus expenses. Okay, or we could go to break even, income equals expenses. So either way would be fine. I'm going to use income equals expenses. So let's see. Startup costs for Mary's business was $45. So that's a cost. So I'm going to put that over here on the expense side, $45. Okay, for each bracelet she sells, she earns $2.50. So if you use that $2.50 as income, that's okay. She sells, she earns $2.50. So that's $2.50. Now that's for each bracelet. We have to multiply that by the number of bracelets. Oh, see, we forgot. Here's our unknown. How many bracelets? So we're going to let B equal the number of bracelets. Okay, so that's $2.50 for each bracelet times the number of bracelets. So that's her income. Okay, but it also costs 75 cents for each bracelet, right? So that's adding to the expenses. So I'm going to put over here plus 0.75B. Okay, it adds to the expenses, that's why it's plus. Now you could do this a different way. You could say, well, you could take the 75 cents off the 250 already and just say, well, she's going to make $1.75 for each bracelet. In which case you would have this 1.75B equals $45, which is exactly what we would get if we subtracted 0.75B from both sides. Okay, and then we could divide by 175. Okay, so let's do that. 45 divided by 1.75. Okay, so if I divide by 1, I hope I did this right. It doesn't come out to be a nice whole number. 45 divided by 1.75. I got 25.7, so I'm going to write that, realizing that she can't make just exactly 25.7 bracelets. Not only that, it's a repeating decimal. The number of bracelets should be a whole number. So we're going to call her break-even point 26 bracelets. because that's the closest whole number to the number of bracelets that she can make and sell. So there you go. There's your introduction to like using algebra to solve those word problems. Good luck with the assignment. Be sure to use Canvas chat if you have questions, and I'll do my best to help you. Also, email is fine too, if you feel more comfortable with that, and I'll get back to you.